All right, today we're going to start our notes on Unit 3.4, talking about algebraic proofs. We're going to start off by talking about just the properties of equality. Those are properties that you've been using to solve equations ever since day one. Now we're just going to refresh our memory on those properties. The addition property says that if A is equal to B, then A plus something is going to be equal to B plus that same something, right? So as long as I'm adding the same thing to both sides, it doesn't make the equal sign untrue anymore. Same thing with subtraction. If A is equal to B, then I can subtract something off of both sides, and it doesn't change the value or make it not correct anymore. And same with multiplication. If A is equal to B, then A times C is equal to B times C. And same thing with division. If A is equal to B, then A divided by B is equal to messed that up. If A divided by C is equal to B divided by C. So as long as I'm dividing by the same thing, it still equals. All right, so those are what we call the arithmetic properties, addition, subtraction, multiplication, division. That's why it's called the arithmetic properties. Next, we have the distributive property. The distributive property says that we can distribute the A to both the B and the C. So it's going to be AB plus AC. We can just multiply both the things inside the parentheses by what's outside. Substitution property says that if A equals B, then A may be replaced by B in any expression or equation. So we can just replace what A is equal to if we need to. Next thing is kind of like no duh, right? So for any real number A is equal to A. And that's because a value will always equal itself. All right. The next thing we can do is the symmetric property, and this is another one kind of like no duh. If A is equal to B, then B is equal to A. All right, so we can kind of just flip things over from left side to right side if we need to. And the last one, we kind of combine the symmetric and the substitution property. If A equals B and B equals C, then A equals C. All right, so at this point, I want you to pause the video and try to fill in all of these blanks on your own, and then after you're done pausing it, come back and I will have I'll have it filled in for you, or I'll fill it in with you. So go ahead and pause it now. Okay, so you should have paused the video and filled this out. If not, it's not really helping you any, but we'll go ahead and fill these out together. If K equals 3, then 3 equals K. That is the symmetric property. If 2x 14, then x equals 7. That is the division property. I'm dividing both sides by 2. (10y equals 10y). Well, yeah, obviously. That is the reflexive property. If negative 5x minus 1 equals negative 11, then negative 5x equals negative 10. Well, what I've done is I've added 1 to both sides, so that is the addition property. If 10a equals 2b and 2b equals c, then 10a equals c. That is the transitive property. Number 6, negative 7 parentheses n minus 4 equals negative 7n plus 28. That is the distributive property. Number 7, if 6y equals 24, then 6y minus 3 equals 24 minus 3. That is the subtraction property. Number 8, if 10x plus w equals 41 and w equals 1, then 10x plus 1 equals 41. So that is the substitution property. Number 9, if 3x equals 2y and 2y equals z, then 3x equals z. That is the transitive property. Number 10, if 7m equals 35, then 7m plus 4 is equal to 35 plus 4. Notice I've added 4 to both sides, so that is the addition property. Next, 11, if negative 2c equals 18, then 18 equals negative 2c. Just flip from one side to the other, so that is the symmetric property. Number 12, given 3x squared plus 1, if x equals 5, then 3 times 5 squared plus 1, that is going to be the substitution property. Number 13, if m equals negative 2, then 8m equals negative 16. I have multiplied both sides by 8, so that is the multiplication property. And number 14, 5x plus 8x equals x times 5 plus 8. Not normally how we would write this, but it's kind of backwards. It is the distributive property. All right, so all of that hopefully is a review. You've learned all this before. Today our focus is going to be on writing a two-column proof. A two-column proof is a common format used to organize a proof. There's other ways to do it. We're going to focus in this class on a two-column proof. A two-column proof. So the first thing we're going to do is the statements. The statements, or the steps, are listed on the left side, and the reasons justifying each statement are listed on the right side. So what can be used as reasons? Well, there's those properties that we have listed. Also, you can use definitions, which we will definitely be doing starting next class period. You can use postulates, which again we will be using soon, and you can use theorems. All right. So, to write a proof, first off, we're given some bit of information. So if you notice here, our given is that 4x minus 1 equals 27. And then we're asked to prove something. Or it might say if and then. Okay? Given 4x minus 1 equals 27, prove x equals 7. So the 4x minus 1 equals 27, that's always going to be where I start. This x equals 7 is always going to be where I end. Okay? Those are always going to go in the first and last box on the left side. Now, the reason why I can write that first statement there in the first box is because it is given. Our first reason almost always will be that it is given. All right? Then from there on, I'm just trying to figure out what property or definition or postulate or theorem did I use to go from step 1 to step 2. So, to go from the first box, 4x minus 1 equals 27, to the next box, 4x equals 28, I can see that I've added 1 to both sides. So that is the addition property. And then I can see that I went from 4x equals 28 to x equals 7. I've divided both sides by 4, so that is the division property. And that's all I have to do for these. Number 2, a over negative 6 plus 2 equals 5. I want to prove that a equals negative 18. So my first statement, that goes in the first box. This second statement, a equals negative 18. Notice I have that there next to number 3. So my first reason is that it's given. And then I got to figure out, I'm playing detective here, I got to figure out what happened to go from step 1 to step 2. Well, it looks like they've subtracted 2 off of both sides. So we're going to say they use the subtraction property. And then, if you notice, to go from step 2 to step 3, it looks like they have multiplied both sides by -6, so that means they've used the multiplication property. A lot of times I'm just going to abbreviate that to prop. All right, so step 1, -9 times 2x minus 3 equals 63. Again, that's been given to us. I want to get to where x is equal to -2. So again, that's my first box and last box. Now I'm trying to figure out what steps happen to go from, we're going to go step by step. All right, so what happened in the first is that they used the distributive property. Then to go from -18x plus 27 equals 63 to -18x equals 36, they subtracted. So that's the subtraction property. And then it looks like they have divided both sides by -18, so that is the division property. And that's all there is to these proofs. All right, number 4. Oh. 6x minus 2y equals 14. I want to get to y by itself. Y equals 3x minus 7. So that's my first and last box on the left. Reason number 1 is that it's given. Then if you'll notice, I've subtracted 6x off of both sides, so that is the subtraction property. And then I have divided both sides by 2, so that is the division property. Number 5, given that m equals 1/2 a plus b, prove that b is equal to 2m minus a. So the first thing I have there is m equals 1/2 parentheses a plus b. Of course, the reason why that is there is that it is given. One thing I forgot to mention in this video, I mentioned in class, is that anything that is given, we can accept as absolute truth. There is no reason to question a given statement. We can assume that it is the truth. All right? So assume that anything given is going to be true. So given that m is equal to 1/2 a plus b, well, how do I go from that to step 2, which is 2m equals a plus b? Well, I've multiplied both sides by 2, so that is the multiplication property. Then I went from 2m equals a plus b to 2m minus a equals b. So I've subtracted an a off of both sides, so that's the subtraction property. And then lastly, I haven't really done any math here. I've just switched sides. And that property allows me to switch the left side to the right and vice versa is the symmetric property. All right. For number 6, I have f plus g equals k plus 7, and I'm also given that k equals f. Now both of those are given to me, so I'm going to write that in box 1 and 2. And I'm going to write that given as the reason for both of them. My last box on the left is what I'm trying to prove, which is g equals 7. So if I have f plus g equals k plus 7, and I also have that k is equal to f, well, I can substitute in an f for a k, so that's using the substitution property. And then I can subtract an f off of both sides to give me g equals 7, so that's the subtraction property. For number 7, I'm given 3 statements. I'm given that P is equal to 3Q, P plus Q equals R, and R equals 20. So the reason why I write all of those first is that they are all given. P plus Q equals 20. I can make that statement true because I can substitute in a 20 for an R, because I know that that is true. So substitution property. Number 5, 3q plus q equals 20. Again, that's kind of like saying, well, if p plus q equals 20 and p equals 3q, then 3q plus q equals 20. That's the transitive property. Or I can see why you would say that's also the substitution property. Both of those would work there, transitive or substitution. Now, to go from 5 to 6, we didn't really use any properties. We didn't have to like do anything to both sides. We didn't even distribute. All we did was clean up one side. And when we clean up, we're not really doing anything other than combining like terms or something like that. So we just simplify. And then lastly, to go from 4q equals 20 to q equals 5, we divide by 4, so that is the division property. All right, and that is it for the notes today. If you have any questions, please shoot me an email or a text, or not a text, a Canvas message, and I'll get back to you as soon as I can.